All right, we are going to play a level 2 game. So we're going to move our marker there to show that we're in college now. This is a level 2 game. We're going to reset our voltage across the channel. I already removed all the tiles. I removed the insulator tiles from there. And we need to find out what our new project is. So we are now getting funding from Loud Wasabi, and we're trying to make a hydrogen fuel cell powered electric motorcycle possible. All right. And we're going to do this by making transistors, this thing, that can handle lots of electricity flow. So we have 2 specific project objectives in addition to the general requirement to create the path, right? Our 2 objectives here are to have a channel voltage of 14 volts. So that was the same requirement we had in the high school round or high school game. But we also need to have at least 3 of the insulator tiles with full upgrades. So remember that in the first level, our insulator tiles were pre-upgraded for us, right? They start as silicon dioxide. And we pre-upgraded them to be yessia or yesium oxide. If you know, you know. And so we're now adding a new game mechanic in. And a mechanic is like a thing that you can do in the game. So we're adding in this new action that we can take. And this is going to be documented on a research card. Okay, so just like how we had this option to increase the voltage across the channel, we now have the ability to spend money and roll to try upgrading 2 of our insulator tiles. Okay, ALD is called atomic layer deposition. It's sort of like spray painting with gaseous atoms. When you conduct ALD, you are depositing single layers, like a single layer of particles. And that's going to be really useful for our process right now because we are trying to apply a single layer of these insulators. We're trying to improve our insulators. So ALD is a process that we use in the lab, or that is used in the Bent group, the Bent lab at Stanford. The back of this card sort of shows what it looks like in part of the lab. Pretty cool, technical, lots of ALD reactors. But so we're going to use ALD in that research process to improve our insulators, and that's going to allow us to build up the tiles the way we did in the first round. Because right now, we can only actually put 1 tile in each column because our insulator will only allow 1 tile so far. All right. And if you're thinking, wait a minute, that's not how it actually works, we'll be able to get to how the technical side of things actually works. But right now, this is close enough and it will help the game function and hopefully be fun. So we're going to switch from round 1 and we're going to go to round 2 or level 2, college. All right. So we're also adding in these scientist cards. And scientist cards they give you the opportunity. These are all scientists who are in the Bent group. Okay. And these cards all have a benefit to them. Like they all provide you with an in-game benefit. You'll see that some of them don't have a benefit yet because these are prototype versions of the cards. But these are going to be in a stack on the table. And the cost for each scientist card is $2 or 2 beans. Okay, so you can bribe a scientist. And if you bribe a scientist, you will get help. So bribing a scientist, if you get Bang, Bang's going to help you counteract a lab condition card. And actually, this is a good example because lab condition cards come into play in the Masters level, level 3. So if you get a card that's not relevant in your level, you can put that in the discard pile and draw the next one. Okay. So in this one, we get Nadine. Nadine has a benefit in ALD processes. And now we have an ALD process. So Nadine could be a really useful card. Okay, a really useful friend and researcher who's going to help out. But these are going to be in a pile off to the side of the board. But the cost, again, is $2. So if we take a pause and think about what can we possibly do, with our money this game, we can play one tile, we can play 2 tiles, we can bribe a scientist, we can increase the channel voltage by 1 step, or we can conduct ALD, or try, to upgrade 2 insulator tiles. Okay, and we're gonna have to navigate these different options as we go through the game to complete our project objectives and create the complete path. All right, so things are getting a little more complicated. All right, oh, and actually, there is one more thing we can do. There's something called Moore's Law. From my understanding, I could be wrong. Moore's Law, the gist of it, I'm going to get this wrong. I'm totally going to get it wrong. I'm pretty sure it is that the length of a transistor will get twice as small every some number of years. So if you know, you can describe what it is. I think it's like every 10 years, every year. I don't know. The point of it, though, is that it's this idea that transistors will forever get shorter and shorter and shorter. And so to resemble that, there is another bit of research you can do. You can decrease the channel width by 1 column of atoms. It's more costly than anything we've seen so far. It costs $4, 4 beans. And it's less likely to succeed. You have to roll 1 to 3. But if you do it, you get to overlap 1 space, just like that. Okay. It's a pretty handy feature because, as you can see, it shortens the distance you have to cover to complete the path. Okay. Depending on your project, it may or may not be useful, because right now, we still, because of this project from Loud Wasabi, we still need to end up with a channel voltage of 14 volts. That means we're going to have to upgrade the technology. So we're going to have to upgrade the voltage, upgrade our battery to 14 volts. But it does not mean that our path necessarily needs to be 14 tiles. Okay? The voltage just has to be greater than or equal to the number of tiles in the complete path. Okay? So all of that is to say, for this project, this bit of technology may not really be needed, but you can play around with it. It might be helpful. Okay, so I'm going to take a little pause and then we'll get started.